Riemann sum. I'm going to call it the special C. This thing is long. Dead. Okay, we have the special C Riemann sum. And by the way, I don't think Riemann ever had this, but I'm making it up. It's my own version. Yeah, it's my own version. Okay. So I'm going to take the special C Riemann sum, meaning my height is not going to be the left, right, middle. It's going to be the average value. So I want the average value one, right? So I'm going to take, how do we find area? We're going to take base times height, correct? Okay? Now, what is base? The base is B minus A, agree? So we're going to find the area then. So base is equal to B minus A. So I'm going to put this capital B so you don't get those confused. Little b is the coordinate, big B is the base. Actually, in geometry, that means the area of the base, but whatever. Yep.
Does it matter if it's F of B or G of B?
It does matter, but right now we're finding this area, which is G. And then when we find the area, we're going to end up with the displacement, right? That's what we're going to try to get, okay? So this is so simple, it's ridiculous.
Oh, it's the displacement of the
This is the base. Now, what is the height? The height is 9, right? What does 9 represent here? 9 is the average. Isn't 9 equal to that thing there?
Yeah.
That's the slope for this. So what's going to happen when I do this? So I'm going to multiply it by this. Do you see what's going to happen? Gone. And that's your answer. Do you see it? Do you see it? We took base times height, it canceled, and this is what we actually said is the actual formula. Come on. Okay, now everybody's got to go, ooh. Okay, that was do we see what happened? Okay, so we proved it, and that's a very, very formal proof. It's very visual, and it's actually quite logical, and it's quite simple. So that's why the area of this is equal to that. Base times height. So did we really just do a Riemann sum? So there is a perfect Riemann sum. And I've only seen that in one book. And it was the first book I ever used. If I never saw that, probably never thought of doing this one. Because I never thought logically that, whoa, you have to have a perfect height. Okay, now, there are two theorems in the book, and you may or may not have seen them, but I ignored them because I thought they'd be confusing. There's two mean value theorems. So then we're going to explain this. Alright, we have two mean value theorems. Okay, we have the derivative mean value theorem. And you're going to see it in your book, or you'll see it on tests, and you might get confused. That's why I waited until the end to do this. You have a derivative mean value theorem, and you have an integral mean value theorem. Now, let's analyze what that actually means. What did we call this guy when we did integrals? Mean value. No. That's the mean value theorem. What did we call this guy? The average value theorem, right? So when they say the integral mean value theorem, they're really saying the average value. So the one we actually did was not. This is the actual meaning of it, but this is the way we'd actually say it. Okay, what does average mean? It means the rate of change, right? Average rate. It's not an average value. All right. The mean value theorem. So there's two mean value theorems. The average value here is 9, correct? You guys with me?
Yes.
The mean value theorem is this guy, where there has to be a tangent wherever the average rate of change is, right? And so the mean value theorem derivative is going to be this guy, 9. Now, isn't that the exact same answer? Do we see that? So the mean value theorem for the derivative is the same as the mean value theorem for the integral, but it's called a different name because they're in different contexts. This mean is your average rate of change, and this is your average y value. You see the difference? You guys got to look more passionate. Yeah. Woo! You gotta stop thinking. Now, this is kind of rich stuff. Do we see? Now, when I do problems, when I do stuff, when I prepare, I always picture those two functions in my mind. This is the original function, that's its antiderivative. I have the mean value theorem, I know the average value, so I know how they're related. When they give you tests in the AP test, you're not inspiring me.
Huh? Oh, sorry.
Okay, I guess I'll blame it to after lunch. Stuff like that. Do we see how it's related? Do we get it? Can you explain it?
Yeah. I can try.
Very few people have done it well. Okay, and each year I try to get a little stricter because I had a lot of the smart ones last year from BC and I marked them. They had to redo the whole thing. I said if you do poorly in this section, I don't even care about the rest of the portfolio. The rest of the portfolio is just portfolio. The rest of the portfolio is nice, but this is the core, and it's so important because we use it so much in this class. It's kind of cool. All right. So let's see what we have to do. You found that really interesting? So when you find it really interesting, do you guys like to sit there and go?
We're thinking about it. Really
Smile.
process.
Okay, you could go. You could start trashing cross so that you have to wake up. All right, so that's pretty good. So is it true that there is only one mean value theorem? It just depends on which context you're in.
So that's the derivative of the original function, and then the integral is the
Well,
roll.
this is the derivative. Yeah. So the logic is if you're finding the average value, they're both average values by the way. So when they say average value, they want to know what is the average y value here, and that they want to know they want to know the mean value theorem. So when I say mean value theorem, I always mean this one up here.
Mean value theorem is differential.
Yes. So the books will, if you read your books, it will actually say you can have mean derivative and mean integral. But in reality, when they say the mean value theorem on any AP test, they mean the top one. In other words, in my mind, the mean value theorem means there's a tangent parallel to the secant, right? Got it? You guys are not convincing. You got to learn.
Yes.
Yes. Yes.
So to confirm, so when you're saying the mean value theorem, when it's in context of the original function, it would be the average rate of change.
Right.
But then if you want the mean value or the intermediate mean value theorem, that would be the average value theorem, which would be of the derivative function, which is the average y value.
Perfect. You said it exactly right.
Aaron's on.
Beautiful. And they're the same number. See, the key in the AP, the key in doing your AP test is you got to know if you're in the original function or the antiderivative or whatever. You got to know where you're at. Okay? That was said exactly correctly.
Say it again. Minus A.
No, that was too good.
B minus A.
You got it. You got it.
It's the same value, but they use it
In a different context. Yes. That's done well.
So the value of the average speed, which is also this value of the tangent,
Yes.
is also the average y value in the derivative.
In our case, we're going base times height.
Which gives us the exact value, or very close to the area, since we can't use the formula.
Exactly. Wait. What did you say? What did you say?
Use that almost exact value to find the area, which is the same as the displacement up there,
Yes.
the original function,
Keep going.
because we can't use the equation out here.
Okay, I'm not sure what you said. That's all right. We'll figure it out. You'll bug me again. All right. Now we have. Did that make sense? Okay. All right. Now, to me, I as I said, when you do your portfolio, you are going to you have a week and a half to do this work, right? We need to get this guy some caffeine.
He hasn't had caffeine ever.
Caffeine. We do